Hello everyone, dear organizer and participants in the conference. I am Professor Alketa Lame from University of Tirana, and I want to congratulate you for this wonderful organization. I am honored to make a short presentation of work realized in our corrosion laboratory regarding green inhibitors for corrosion. This study refers to the application of Ulmus leaves and Arundo Donax leaves extracts as corrosion inhibitors for hot rolling steel iron B500B, which is widely used in Albania as concrete reinforcement. Why? Where and for what they will be tested? We are talking about our scientific motivation and work idea, because they are very popular plants in Albania, and for more, with low cost of extraction. They contain a lot of green compounds as polyphenol, flavonoids represented by catechin, quercetin in Ulmus leaf extract, and lignin alkaloids represented by donaxarin, sterols by beta-cystosterol, and cellulose in Arundo Donax leaf extracts. They contain heteroatoms, for example, oxygen, nitrogen, p electrons, phenolic rings, etc., which give them good inhibitory properties. Besides other methods to avoid corrosion, use of substances extracted by plants as green inhibitors will be friendly choice for corrosion protection of reinforcement. Material under investigation is hot rolling steels iron B500B, provided from Diler Demir Çelik industry in Turkey, with the composition presented in the table below. Methods using are weight loss and electrochemical methods, specifically potentiodynamic polarization and electrochemical impedance spectroscopy. The exposure time of the samples in the weight loss measurement is 100 hours. For electrochemical measurements, the samples were prepared in the form of the coupons, and the palm sense for potentiostat device with a 3-electrode system was used. For potentiodynamic measurements, the following parameters were used: scan rate 0.1 millivolt per second in the potential range of 120 millivolts. For electrochemical impedance spectroscopy, the range of frequencies used are 100 kHz until 0.01 Hz. First, the result obtained from weight loss. In the table below, and in the two graphs on the both sides of the table, in the summarized and comparative way, are presented the data of both alcoholic extracts, Ulmus leaf and Arundo Donax leaf. In the graph on the left of the table, the progress of the effectiveness of the inhibitor is given according to the increase the concentration and according to the increase the temperature from 25 until 45 Celsius degree. In the graph on the right of the table, the progress of corrosion rate in millimeter per year is given according to the increase the concentration and according to the increase in temperature from 25 until 45 Celsius degree. it clearly seems that for aggressive acidic condition, both extracts present a good protective activity, even at high temperatures, until 81.64% at 35 Celsius degree, refer Ulmus leaf extract, and 75.24% at 45 Celsius degree, refer Arundo Donax extracts. The increase in the effectiveness of the Arundo Donax extract with increase in the temperature indicates a chemical absorption more than a physical one. Maybe the presence of the heteroatoms like nitrogenium in addition to oxygenium give this value. Below, the results of the electrochemical methods of potentiodynamic polarization are presented in two graphs of the open circuit potential and potentiodynamic polarization curves, as well as summarized in the table referring to effectiveness, corrosion rate, and polarization resistance for both extracts. Based on the appearance of the curves, the shift of the corrosion potential, the value of the corrosion current density, etc., this method also clearly shows the protective effectivity of both extracts reaches the value, let's say 85.67% at 100 ppm or milligram per liters for Ulmus leaf extracts, and 85.41% at 50 ppm or let's say milligram per liters for Arundo Donax leaf extract. Both extracts act with mixed anodic and cathodic action. Also, the additional or potassium iodide improves the protective activity in both cases. Iodide ion competitively adsorbed on the anodic side. Furthermore, the results obtained by the electrochemical impedance spectroscopy method presented in the table and in the graphs for one of the extract, for example, of Ulmus leaf, besides others, confirming the results regarding the inhibitory activity of the extract, show that the main process that occurs in the metal solution interface is the charge transfer. This suggests a chemical absorption of the extract compounds. At the end of the measurements and the processing of the results, also supported by the spectral analysis of the extracts, we suggested an absorption mechanism. First, both Ulmus leaf and Arundo Donax leaf extracts are absorbed according to the physical-chemical mechanism. The second, in acidic solution, Ulmus leaf extract and Arundo Donax extract are protonated. Third, protonated molecule Arundo Donax extract and Ulmus leaf extracts are physisorbed in the negatively charged anodic area of iron B500B. And the fourth, the last, the negative charge of these areas is explained by the absorption of chloride or iodide ions. This according by pH of the zero charge theory. Chemical absorption, we are presented in this area of Ulmus leaf extract and Arundo Donax extract occurs between heteroatoms like oxygen, nitrogen, p electrons, aromatic rings with the orbitals of iron. We need to clarify something. Absorption of iodide ion in the surface begins as a physical absorption, but thanks to the characteristic of the iodide atom size, electron pairs, it forms coordinative bonds with the orbitals of the iron. Let's say, finalize a chemisorption. So, at least, and to conclude, we recommend both extracts to use successfully as green inhibitors, protecting iron B500B as reinforcement construction in aggressive acidic solution. Wishing you many success to all colleagues and the conference in general. We thank you for giving us the opportunity to present a small part of our work with green inhibitors. We hope to see and hear from you again. Best regards from Albania, let's say in our language, Miropavshim.